Hello, welcome everyone to my YouTube channel. This is the third video of this Kubernetes 0 series. So, in the last video, we discussed about objects, right? What are the objects in Kubernetes? So, in this video, we will discuss about one of the objects, that is pods. What are pods in Kubernetes or workloads? So, the topic of today's video is what are workloads and pods. Okay. So, first we will start with workloads. What are workloads in Kubernetes? Okay. So workloads are nothing. These are the controllers. These are the controllers in Kubernetes. What are controllers? In the first video, if you remembered, what I explained was this is a cluster. Okay. Cluster has a master node. This was our master node and some worker nodes. These are worker nodes. And in master nodes, we have components like Kubernetes server and this cloud controller. Various components are there. So one of the component was this cloud controller manager. One of the components of master node was controller manager. So this workload is a type of controller manager. What are controller managers? What does controllers do generally? Controllers, you can say controllers are very big processes that the aim of their processes are to control the state of the cluster. Like they continuously check what is the desired state, what is the expected state, and do the changes accordingly in the cluster. So workload is a type of the controller manager. Right. And these workload controllers and like workloads are of four types basically. The first we will explain workloads of the deployment type, stateful set, daemon, and job. These two are less important. We will discuss about these two. These are important things. Okay. These are controllers. So we can say these are deployment controllers, stateful set controller. This controls the stateful set, which controls deployment set. Similarly for these two, right? So first we will discuss what are deployment and what are stateful sets. Okay. And one more thing about workloads are controllers in Kubernetes, and we can say workloads are set of pods. We will also explain pods in the upcoming video, but you can say that if this is a workload, okay, then inside these there are pods. These are pods. Okay. What are pods? That I will cover in 5-10 minutes. But first we need to. Let us explain pods. What are pods? Pods are smallest deployable unit in a cluster. Okay. Means you want to create an application and deploy it. So you create a pod of the application and then deploy it. And that pod can be a type of one of the type of workload. That workload can be deployment of stateful set. So means this architecture is important. I will explain about what it is. First of all, this is a workload. This is workload. In workloads you have pods. Okay, these are pods. Let's say your workload has 3 pods. This is pod. Similarly, this also. In pod we have containers. These are containers. Okay. Inside where your application runs, your application runs inside these containers. Okay. So now you understood the hierarchy, right? On the top is workload. Workloads contains pods. Many pods are there, and inside the pods your application is running. Inside pods there are containers. In one of those containers your application is running. Okay. Now these workloads are of two types: deployment and stateful set. Now, what is the difference between these two? Difference is deployments. Deployments are stateless. Deployments are stateless apps. Stateless means you have a deployment. Okay. You have a deployment. Okay. This is deployment. Now inside pods are running. So all these pods are same. P1, P2, P1, P2. All pods are same. Same means each of these. Let's say if some incoming traffic, some traffic is coming. Okay. We have a load balancer. I just load balancer also, but just assume some service is there. Okay. That directs the traffic to here, P1. Now if P1 goes down, you can suddenly remove this traffic and redirect the traffic to P3. P3 goes down, you can redirect the traffic to P2. Means all pods are identical. All pods are identical. Okay. But what is in stateful set? Is in one more thing is in deployments there is no data involved. Data means there is no database involved here. That's why the both are state. If some data is involved, then there will not be stateless. I will explain stateful sets, then you will better explain what the difference between deployments and stateful sets. So the main thing is deployments are stateless applications. Stateless means all the pods can be changed interchangeably. Means one pod can replace another pod. Okay. This can be interchanged. But what is stateful sets? Okay. Stateful sets. So this is a stateful set. Stateful set is also P1, P2, P3, P4, right? But these are state, as the name suggests, stateful set means each of these pods has different states. Like P1 is not identical to P2, not identical to P3, not identical to P4. Means we can't read the traffic that is getting to P1 pod, and we can't redirect the traffic to P2 because P1 has some data. Here the data is involved. Let's say we have an application that connects to database. Okay, this is database. So these P1, P2 connects to database. P1, P2, P3 connects to database and gets some data. So there is a scenario like some data might be present here which is not here. Means these are not consistent with each other. They has to be consistent, but they are not consistent. Okay, so some data is present here, some is here, some is here. So data present here is not P1 contains a data that P2 might present here. Okay, so when the databases are involved, so the states of the application are different. The state which P1 is in is different from the status P2 is in. So we can't change the pods interchangeably. Now, how if the database is involved, then how this means how where the data is stored. Okay, there is a thing called PV, persistent volumes. Persistent P. We will explain persistent volumes also in next video, but now just again these are storage. You can say these are storage in cluster. Storage devices in cluster. Now each of the pods has its different storage, right? So this is having one PV, this is having one PV, this is having one PV, and similarly this. So each of these will have different data. So that's why the states of these are different. Hope you understood the difference between deployment and stateful sets. Both serves a different purpose. Like when you want applications to have stateless, there is no dependency on any other backend data or any other thing, then we can use deployments. But if there is a dependency to use some databases or to store some kind of data, then we need to use a stateful set. Right? Okay. Now we come to discuss about pods. What are pods? Pods are smallest deployable unit. Smallest deployable unit is when you create application, you need to create a pod or you need to create a workload. Then workloads create pods. Right? You can't directly create a containers in an application. You have to create a pod, then inside the pod containers will be created by Kubernetes. Right? Now pods is smallest deployable unit. Okay, only this much it is. Uh, the important thing is pods lifecycle. There is a life cycle. Whenever a pod is deployed, what are the changes? What are the life cycle that it goes through? So there are, I will say there are five stages are there when an application is deployed. Okay, first is pending state. Second is running, succeeded, failed, and the last one is submitted. So what is the pending state? Pending state means uh, explain here. Okay, we have a pod. Okay. Pod contains container. These are containers. So the pending state means one or more containers is not running. Right? We have three containers here. If any one of the container is not running, then the state of the pod will be pending. Running means all containers are running. All containers in this pod are running. Pod are running. Succeeded. Succeeded means all containers terminated. If they are not in a running state, they are terminated. So it means succeeded. Okay. If code is exited inside the container. Okay. Any error. If any error occurred, any error like application failed to start, right? Or any you say okay. Then these are the failed state. Unknown is a you can say the Kubernetes is unaware what error has occurred. Right? So that can be some application related error. An application related error that might have occurred that Kubernetes is unaware. Then it goes through this unknown error. So these are the states of the pods. Okay. So one important thing I want to repeat again here is who checks these states. Okay, these are the lifecycle states of pods, 5 states. Who check this state? In the first video, I discussed about the kubelet. What is kubelet? Kubelet is a cluster. Right? Cluster has worker nodes. If you have not watched first video, please watch the first video. There I have discussed the complete architecture of Kubernetes. So Kubernetes cluster has worker nodes. The cluster nodes are one of the components known as kubelet. So what is the work of kubelet? What kubelet is? Kubelet, the task of kubelet is to continuously check the states of pods or containers. Okay. And if any of the container is exited or if not running, then restart it or kill it. Means if there is some error, then you need to kill the container. Okay? So means that kubelet checks these statuses. The task of the kubelet is to find the status of the pod, okay, and then do the whatever operation is required. Right? So this I wanted to discuss. Okay. The another thing is okay, the container. Container has also states. We will discuss about container states here. Pod is here. We discussed about pod had 5 stages. Now containers also have states. What states container has? Getting state, running state and terminated. Okay. Now who checks these states? Again, kubelet. Kubelet is there which continuously monitors the states of the containers also. Okay. Now, what is waiting state? So, as I mentioned, like suppose this is the container. In container, what you specify? You specify image, right? Image. Image means Docker image. Docker image of application that you want to deploy. Okay. We provide a static image here. Then Kubernetes runs this image and then inside the container. This was the process, right? So where this image is present? This image is present in artifact. Artifact, artifact is a collection of some repositories there where many images are there. Okay? You know about some public repositories like Docker.io, JFrog repos are also there, artifacts are also there. You get a collection of Docker images or any images are there. So suppose you have provided some image that is so whenever the container starts, first ever, what are the stages? Because whenever container starts, stages are it will fetch image from artifact. Now this fetching image will require some credentials, right? Here some credential it will require either the Gmail ID or anything, any kind of password required that you need to log into this artifact and then pull this image. Okay. Now this process involves some time. This is not instant. When these processes are happening, the container is in waiting state. When these two processes, these number one and number two process completes, the container is going to running state. Now terminated when it occurs, terminated means whenever some error occurs. Error can be anything like somehow the image is not present in the artifact, you provide the wrong credentials or you provide the wrong image name or version, right? Then the container will be in a terminated state. Okay. So hope you understood these basic things about workloads and pods. So in the next video we will discuss about a very important topic called probes. Okay. So hope you are finding this useful, and if you are finding this useful, please do subscribe this channel. It gives me immense motivation to create such videos again. Okay. Thank you so much.